So, as we saw in the Pinhole Viewer Lab, a model of how the light rays work is if you're looking through a pinhole, the light that is being projected into the pinhole, because it's travels in a straight line as a ray, it travels down at an angle, and the top of the tree is projected at the bottom of the screen. The bottom of the tree is projected to the top of the screen. And then if you're projecting left into the hole, it'll project that part of your image on the right of the screen. So anytime you look through a pinhole, you end up, or through the pinhole viewer, you end up flipping the image, not just up and down, but left and right as well. This is very similar to how your eye works. So, a little bit about the anatomy of your eye. You've got some of the obvious things: the eyelid, the pupil, the iris, and the sclera. The inside of the eye, the anatomy of the inside of an eye, it's a little bit hard to read this, but the most important part of the inside is the retina. That's going to be one of the key um, parts of your eye that's involved in what you see. So, as light hits your eye, it travels at an angle and hits your retina. And that retina is very similar to the screen that we used in the pinhole viewer. So, that's where your image of what you're looking at is projected into your eye. So, the light that passes through the lens of the eye focuses light into the retina. The different shaped lenses can cause vision problems when the lens doesn't focus the light right. So, here are reasons for many of people's vision problems. The shape of the lens here um, is what we would have if we had normal vision, but I want you to notice how the image is flipped just like it was flipped in our pinhole viewer. What's nice is that our brain is a miraculous organ, and it is able to take the upside down image and turn it right side up. If you're short sighted, the lens actually projects the image a little closer than where it should be reflected in your retina, and it causes a blurred vision. So, for short sighted people, they can see things close to them, but it's really difficult to see things far away. If you're farsighted, the image actually gets projected behind your retina, and it's still flipped, but this is for people who have to hold maybe the newspaper further away from their face or a book further away from their face because they can only see things far away. And that's generally what happens to your eyes as you get older. There's um, another vision problem called astigmatism, and basically that's when the lens of your eye is a little more distorted. It still projects on the retina, but because the lens distorts the image, it causes blurred vision as well as kind of a shift in what you're seeing or a shift in the object. So, the Pinhole Viewer Lab was very much a model of how the eye works, and you were able to see how objects are flipped when you look at them. You were also able to see the clarity and the blurriness or the brightness and size change as your screen moves forward and backward, depending on your pinhole. Um, so that concludes our lesson on the pinhole viewer and how it relates to how the eye works.